Okay, recording now. It says, question 2. A carpenter makes wooden tables and chairs. Now, he takes 10 hours to make a table and 4 hours to make a chair. So let's begin with that, all right? Let's begin with that. It says, find a model for the time required to make a table and a chair. All right, so again, model means finding the equation. And we know the time it takes a carpenter to make a table is exactly 10 hours. So look at this. Let me ask you a question. And hopefully you can write it in the chat. Let me ask you a question. How many hours does it take for the carpenter to make 2 tables? How many hours, please? All right, so Faye is saying 20, Juan Sebastián Parrado 20, Juan Camilo Alba 20, Carlos Zaza 20, Luna 20. All right, everybody's got it right. Pretty good. And it makes sense, right? Because he takes 10 hours to make 1. So if you want to make 2, well, it takes 20 hours, right? Let's make it a little bit harder. How about instead of 2 tables, what if the guy wants to make 10 tables? How much time, how many hours, sorry, is the guy going to spend? Okay, I see a lot of hundreds. Beautiful. Beautiful, you guys got it right. Congratulations. All right, and it makes sense again. If the guy spends 10 hours by doing just one chair, 10 hours. If you want to make 10, then it'll be 10 by 10, right? And that is the key word there, by. We're doing a multiplication. Yes, Juan Camilo Alba. It'll be 10x. Also, I don't like to call x here. I like to write it as t for tables. But yes, this is exactly the idea. So the time it'll cost to make just tables will be 10 hours for each table we do. Let me just write this t using a different color. All right. So, but this is just the tables. So remember, t stands for tables. So if you replace t for one table, then you would spend 10 times 1, so 10 hours. Did you see? This is a model for hours. How about 10 tables? You put a t instead of a t, you put 10 because 10 tables. And it'll be 10 times 10. Then the amount of time, the amount of hours will be 100 hours, 10 by 10. All right. But this is exactly for tables. We cannot forget about the chairs. The carpenter makes tables and chairs. So let's try to analyze this with the chairs as well. The guy says that he spends 4 hours per chair. So let me ask you something. Hopefully you can write it in the chat. If the carpenter wants to make 2 chairs, just 2, how many hours will he spend? All right, congratulations. I can see a lot of 8s. 8 hours, 8. All right, pretty good. And do you see what we're doing there? We are multiplying the amount of chairs by the amount of hours. Again, multiplication. That is the key word right there. So we also know that 4 hours has to be related to the amount of chairs. This C will stand for chairs, all right? So we have T for tables and C for chairs. But the question is, how do I relate these two? What do I do with these two pieces of information? Do I add them? Do I subtract them? Do I multiply them? Do I divide them? What do I do with these two? Add. All right. People are saying add in the chat. All right. The answer is add, of course. But why? Why do I add them? All right. Easy. Because the time I spend doing tables and chairs has to be the addition of the time of the tables and the chairs. If I do one table and one chair, 1 and 1, Then I will spend 10 hours for the table and 4 hours for the chairs. That means 14 hours. 10 and 4. So yes, the solution here is an addition. Let me just write it real quick. Addition. So over here we have our model for the hours, for the time it takes the carpenter to make tables and chairs. That'll be question A. How about B? Find a model for the cost. Ooh. But I guess we can do this pretty fast now, right? The cost. All right, the cost. Let's take a look at the question and see what we find about the cost. All right, the cost, it says, on the second line, it says, the wood cost $120 for table and $40 for a chair, right? So we can do the same analysis right here. I could ask you how much money would he spend? What would be the cost, right? If the guy wants to make 2 tables or 10 tables, right? But I guess you got the idea now. I guess you understand now that to get the cost, all you need to do is multiply the amount for each times the amount of tables or chairs we do, right? So in this case, the cost will be $120 per table. So I'm using the same variable that I used before because we are using the same tables. And we're going to add it to 40. It says 40? Yes. To 40, which is the cost of each chair. So look at that. Now we have our second model. One model for time and one model for the cost. How do we know if this works or not? You can just do a real quick replacement of values in your head. You can just think to yourself, all right, how much would it cost to do 1 table and 1 chair? All right, 1 table would be 120 and 1 chair would be 40. So 120 plus 40, that will be 160. Yes, Juan Sebastián Parrado, 160, yes. So if we replace the T and the C by 1 each, because I said 1 table and 1 chair, this will be 120 times 1, 40 times 1, so 160. That means our model kind of works so far, right? You can change the T and the C by the amount of tables and chairs you want to find. You can do it with any example you want. You can find how much would it cost for 10 or for 5 or whatever, right? That is exactly how you find if this model works or not. All right, so that is question A and that is question B. Let me just write over here. Question A and question B. This is for the point 2. All right. Let's jump into the C. C says, the carpenter works 70 hours 1 week and spends $160 on wood. Okay, so now we have extra information. Now we don't have a model for the time and the cost. No. Now we have an exact amount of time and an exact amount of money he spends. Look at that. He says he works exactly 70 hours. So for question C, I'm going to write it here. For question C, the time will be exactly 70 hours, right? That'll be the time. And the cost will be 760. So the cost will be $760. I'm not writing the hours and I'm not writing the dollars because so far we just want to find the values. But at the end, I'm going to have to write dollars and in hours and all of that. That is the units of the example. But as of now, we can forget about the units and we can put them later. All right, the carpenter works 70 hours, that is the time, and he spends $760 on wood. Okay. Find the amount of tables and the amount of chairs. So again, just like in question 1, you can do this by two ways. Number one, the first way, you can come up with ideas, come up with numbers, tables, and shares that you think gives you 70 hours expended and here 70 hours expended and $760 expended. You can come up with those values, see if it works or not. So for example, I'm seeing somebody just said 10 shares, no, 6 tables and 1 chair. Sophie Gonzalez. All right, let's see. Maybe that works. So 6 tables and 1 chair. All right, let's see if it works or not. This is a possible combination. So you can do this. You can try to find values that give you, that when you multiply it here for the time gives you 70. Let's see. So 60, 6 times 10, that'll be 60, right? And 1 times C, 1 times 4, right? Because 1 is C, 1 times 4, that is 4. So 60 plus 4 will be 64, not 70. Real close, but not exactly on the dot. So this is not a good combination. The carpenter didn't do 6 tables and 1 chair. No, he needed to do more. Yes, because we only spent 64 hours and we had 70. So how do we do this? Is there an easier way of finding this? Yes. Yes, there is. Doing a system of equations. Look at this. We know the time is 70 and we know the cost is 760. So now we have 2 equations. We have two equations for our system of equations. Instead of time, I'm going to write 70. 70 equals, and I'm going to write down the entire model again, 10t plus 4c, right? That is our first equation. Instead of time, I'm writing 70 because that is the amount of time the carpenter expended. Now, for the cost is 760. So 760 will be 120t plus 40c. All right, look at these, guys. Look at these. This is a system of equations, and it can be solved by doing substitution or elimination or a bunch of other processes that we didn't see in class. Which one do you want to do? I'm thinking elimination, maybe, because all you need to do is multiply the first one by 10, right? Over here you have 4, over here you have 40. You can multiply the first one by 10 and get a 40 over here. Cancel the C. Did you see? All right, who has the answer now? If you do it with elimination, who can tell me the answer, please? T equals and shares equals. Does anybody have the answer now? Let me look at the chat, see if anybody have the answer. Juan Camilo Alba, T is 10. You see, I don't think so. I don't think so. T cannot be 10, right? 10 shares, maybe. 10 shares. But T10 is a mistake. Because look, Juan Camilo Alba, if you put 10 here, 10, T equals 10. That's what you said, right? T equals 10. If you put 10 instead of the T, right here you will have 10 by 10. This is 100. We are already way over 70, which was the amount of time. We are at 100 hours. So that's how you know you made a mistake, right? Okay, we have 2 other options. We have shares 10 and tables 3. All right, let's write it down. Tables 3 and shares 10. Let's see if it works. Juan Camilo Alba is saying this is the answer. Also, Daniel Osorio is saying this is the answer. Laura Anzola said only this, chairs 10. Okay, Juan Sebastián Parrado, sorry. Did you check it? Sebas Parrado, did you check it or not? Maybe you did. Yes, Luna Campos, yes. All right. These people check the answer. Beautiful. Now the question is, but teacher, what is that? What do you mean by checking the answer? What is that? Easy. Go ahead and replace the value of t by 3 and replace the value of 10 by c. It should give you, in each equation, should give you the value of 70 and 760. It should. If it doesn't, then we made a mistake somewhere. All right, let's do it real quick over here. If we replace the value of t, we're gonna have 10 by 3 plus 4 by c, but we need to replace the value of c by 10. So this will give you 30 plus 40, which is exactly 70, which is the value of the first one. So the first equation is checked. It is correct. We cannot just do the first equation. We need to do both. If you just do the first one, you may have a mistake. You need to do both. Don't be lazy. All right, the second one. This will be 120, and inside, you're going to replace the t for 3. So inside the parentheses, you're going to put a 3 plus 40 times c. Instead of the c, 10. This will give you 360 plus 400, which is exactly 760. And look at that. It's exactly our answer for this one. So the second equation is checked. So yeah, the answer for C, the answer. How many tables and how many chairs did the carpenter create? Well, he created, this is how you write the answer. Answer. He did, or he made 3 tables and 10 chairs. All right. Over here, we have our answer. This would be the answer for C. All right. The answer for A, the answer for B, and the answer for C. That'll be all, guys. Right now. Does anybody else have another question? Because we only have 4 minutes for the class. That's all we have. I need to disconnect so that you jump into the workshop. If I continue doing this, you guys are not going to go to the workshop. I know you. You guys are going to continue with me trying to solve the exercises, right? Because maybe you like the class, right? Maybe, hopefully. So maybe you continue with me and you don't do the workshop. That's not good. Remember, at exactly 3 minutes, the workshop over Alex is going to begin. All right? So, we have 3 more minutes for questions. Does anybody else have another question, guys? No, I don't see anybody having more questions. Okay. Sip of water. No? Okay, beautiful. I'm going to stop the recording now. And again, if you happen to have more questions, just let me know. Juan Sebastián Parrado. Mister! What's up, man? What do you need? What's up? All right. David Andrés Castro. 3D. Juan Sebastián Parrado. 3A. Okay, I'm going to go with 3 then. But I'm going to do as many as I can, as much as I can. If I cannot do it all, I'm sorry I tried, but we only have 2 more minutes, all right? Okay, let's see. 3. Let me erase all of this. Let me just erase all of this there. Okay. So people in the chat are asking for the question 3A, 3C, 3V, 3D. All right, I'm going to try to do it all right? I'm going to try to do it all. So let's begin. A line passes through points -3. Let me just write it. Let me just write the points. -3, comma, -2 and 4,5 and 4,5. All right, so we have our point 1 and we have our point 2. So a line passes through those 2 points. A, find an equation for the line in point slope form. All right, in case you don't remember or maybe you didn't see it. Point slope is different than slope intercept, which is different than standard form. Standard form. Okay, what is the point slope? For those of you who don't remember, the point slope, what's going on with the camera here? Can you guys see me? All right. What is the point slope form? All right. For those of you who don't remember, the point slope form is the one that you just replace the values in the regular formula. This would be y minus y1 equals m times x minus x1. All right? If you replace the values of y1, x1, and slope, this will be the point slope. We're using 1 point and the slope. 1 point and the slope, right? This one is different than the slope intercept. The slope intercept is this form, y equals mx plus b. Why it is called the slope intercept? Because over here we're using the slope, which is m, and the intercept, which is b. All right? And the standard form will be the equation ax plus b, y equals c. That'll be the standard form, all right? Let me just do the first one, then the second one, and I don't think we can do the third one now, because right now it is 10:01. So you should be doing the workshop. Let me try to do this as fast as possible. The first thing we need to do, look, for the point slope and the slope intercept, we need the slope. That is the first thing. For these two, we need the slope. So let's find the slope real quick. The slope will be, again, y2 minus y1 over x2 minus x1. Does anybody have it? No? All right, y2, 5 minus y1, -2. x2, so 4 minus x1, so -3. This is the slope, right? Remember, we just saw the formula in, I don't know, I guess question 1 or question 2. I don't remember the formula. M equals 1, Daniel. All right, let's see if 1. 5 minus -2, this will be 5 plus 2, which is 7. And then 4 minus -3, so 4 plus 3, which is 7. So yes, 7 over 7. In this case, 1. Daniel Osorio, you did it correctly, my friend. Laura Valentina, perfect. Estefania, excellent. Also, Stefania, it's not y equals 1, it's m. M equals 1 is the slope, all right? But you did it right. Beautiful. So we have the slope now. We have this part and this part for the point slope and slope intercept form. Look at this. Paso un momentico al español. De pronto en el taller les aparecen preguntas de esta y van a decir, ay, pero ¿cómo así esa forma? No me acuerdo cuál es. Lo bonito en matemáticas es que le pusimos nombres para no tener que acordarnos. Mira esta. Esta se llama slope intercept. Se llama así no porque seamos los super creativos, sino porque le pusimos esos nombres para no acordarnos de cosas. Mira, slope intercept significa que tienes que usar el slope y el intercept. Por eso es esta. Esta no usa el intercept. Esta no usa el intercept. Tiene que ser esta. Esta sí usa el slope, pero no el intercept. Esta ni siquiera usa el slope. Entonces no es esta. ¿Me hago entender? De esa manera te permite a ti saber cuál es la forma. ¿Cuál? Esta de acá es, no sé cuál. Bueno, leyendo el nombre. Mira, leamos la de acá. Point slope. ¿Qué significa point slope? Bueno, pues que vamos a usar un punto, point, un punto, y el slope. Pues esta de acá, bueno, esta de acá podríamos pensar uno que usa también un punto, pero esta es el intercepto. Esta de acá es en la que uno intercambia los valores de x y y por un punto. Esta de acá no estoy ni siquiera usando el slope, entonces esta de acá no es. El nombre que le aplicamos nos permite saber cuál de las ecuaciones es. ¿Y truco para standard form? Sí, no hay. No hay truco para standard form. Esa sí toca aprendérsela. All right. So let's find the solutions of all of these real quick. The first one. All you need to do is replace the values. That's all you need to do. Replace the values of y and x1. y1 and x1. These are the points. Point 1, -3, -2. We're going to replace for these ones. So our solution will be y minus -2, which is the value of y1, -2, equals m, which is 1. And inside the parenthesis, x minus x1, which is -3. All right. By doing some algebra, negative and negative will be positive. So y plus 2 equals negative and negative will be positive. So this will be x plus 3. X plus 3. And I'm not going to put the 1 because every number multiplied by 1 is the same number. So this one right here is the solution for our point slope intercept. How do you find the slope intercept now? Simple. Take this one over here and isolate y, because that is the idea here. Slope intercept has the y isolated. Pass everything that is not y to the other side. So y plus 2 becomes y equals, pass the 2 to subtract, so x plus 3 minus 2 again, pass the 2 to subtract. We are isolating the y from the first equation. In other words, y equals x minus 1. I'm sorry, plus 1. Positive 3 minus 2, so plus 1. Over here, we have our second equation. All right, pretty good, pretty good. And how about the last one, the standard form? How about the last one? Okay, so we need to isolate the final value. Look at this. We have x with a coefficient, y with a coefficient, and on the other side of the equality, we have c, a regular value that doesn't have the x or the y. So you're going to work from the second, from the slope intercept. You're going to work from here. Look at this. We have the y with a coefficient. The coefficient of y is 1. We have the x with a coefficient. The coefficient of x is 1 as well. And we have the value of c, the value that doesn't have x or y, the value that is not being multiplied by nothing. This one will be our c. So we just need to isolate 1 from the second equation. If we isolate it, what we need to do is pass the x to subtract. So this will be the solution. Y minus x equals 1. And there we go. Final solution. All right, that will be point A, point B, and point C. Now for D and E, my friends, we don't have enough time. I am really sorry. I really need you to go online and work on those workshops because those are the real deal, right? This was practice. The workshop is gonna give you the grade, all right? So yeah, just go, please. I can't. Juan Sebastián Parrado, I can't, my friend. I can't. Juan David Vega, el último, Juan Sebastián Parrado, solo el último, I can't. Sorry, guys. I need to stick to the time of the workshop. So please, just go to the workshop and try to do it. Daniel Felipe Osorio asks, ¿esta workshop da puntos? Mira, this one that we just did, no, it doesn't give any points. This was for practice. But the one you are about to do in Alex, that one gives points. Not points to be precise. It gives you a grade, the grade of the workshop. All right? Juan Camilo Alba. ¿Por qué da menos? Where? This negative? This negative? Juan Camilo Alba, this one? Yes, all right. Simple, again. From this equation, you are going to find the standard form. And to do that, pass the x to the other side to subtract. Remember, we are trying to isolate C. Isolate C, right? To isolate C, take everything that is not C and put it on the other side. So the x, which is adding, look, the x has no sign there. That means the positive is implied. So this x is positive. You pass it to the other side, it will be negative. Okay, Juan Camilo Alba. Gracias, profe. My friend, no worries. I'm here for you. Just go, please. Only 8 people have left and gone to the workshop. So please, everybody else, go. Go, real fast, real quick, go. See you guys in the next one. I'm gonna upload these 3 questions. I'm gonna upload them to a YouTube channel that I'm creating for these classes, and you can find it in the resources page. All right. So bye guys. See you around. Bye. Juan Sebastián Parrado. Chao, profe. Chao muchachos. Chao.